we say that a field is perfect, a field F is perfect if every finite extension of this field is separable extension. Okay, so if it is finite extension, then it should be separable extension. So a field is perfect, a field F is perfect if the K by F is finite extension, then it must be a separable extension. So we will prove a result for a field of characteristic 0. That is, if characteristic of F is equal to 0, then this field is perfect. So every field of characteristic 0 is perfect field. Okay, so proof. So consider characteristic of F is equal to 0, and we want to show that every finite extension of F is separable extension. So let us consider a finite extension of F. So K by F be finite extension. Okay, we want to show that this is separable extension. Okay, we want to show that K is separable over F, right? So to show that K is separable over F, we have to show that K, it's an algebraic extension, and every element of K is separable over F here. So let us consider an arbitrary element alpha belonging to K. Okay, then K will be separable extension over F if alpha is separable over F, and alpha will be separable over F if alpha satisfies a polynomial over F having no multiple roots. Okay, so let us consider the degree of this. It's a finite extension. Let us consider its degree as equal to n. Then alpha satisfies a non-zero polynomial f of x in a ring f of x of degree at most n. Okay, because the degree of this extension is n here. So f of x is a non-zero polynomial satisfied by alpha, and its degree is at most n here. So alpha satisfies this, so f of alpha is equal to 0. Now let us consider this polynomial, and we can take the help of unique factorization theorem for polynomials over a field. So I can express this polynomial f of x as a product of irreducible elements in f of x. So let us take those elements as q1 of x, q2 of x, and so on, qm of x, where each of these qi of x are irreducible elements in the ring f of x. This is for every I between 1 and m. Okay, now what we have, f of alpha is equal to 0. So f of alpha is equal to 0. It implies q1 of alpha into q2 of alpha, and so on, qm of alpha is equal to 0. So for at least one I, we have qi of alpha is equal to 0. So it implies that qi of alpha is equal to 0 for at least one I. Okay, between 1 and m. Okay, so what does it imply? It implies that alpha satisfies an irreducible polynomial qi of x in f of x. Okay, what is the characteristic of f? Characteristic of f is 0, and qi of x is irreducible. So what we have, characteristic of f is equal to 0 and qi of x is irreducible in f of x. So it follows that this qi of x cannot have a multiple roots. Okay, so this cannot have multiple roots. Okay, so alpha satisfies a polynomial over f having no multiple roots. So it implies that alpha is separable over f, but alpha is arbitrary element of k. So every element of k is separable over f, and hence k is separable over f. And again, this extension, we have taken an arbitrary finite extension. So every finite extension is separable extension. This completes the proof.